And welcome back to Teacher Gimble's channel. Today we're going to be going over Illustrative Math, Geometry, Unit 1, Lesson 4, Practice. If you like this video, please make sure to like and subscribe so you can continue to see more like this. Let's get started. Problem 1. The diagram is a straight edge and a compass construction. So we're looking at this diagram over here. The center of one circle, A is the center of one circle and B is the center of the other. Explain how we know ABC is a quadrilateral. Now, in the previous few lessons, we've already talked about this a few times, but I'll quickly go back over this because the theory behind this specific construction is going to be the theory behind most of the questions in this video. So let's get started. I want to talk about circle B. We have the center over here, and circle B is the blue one that I'm highlighting. Now, the definition of a circle is that every single point along the edge of the circle is equidistant from the center. So that means that the distance from the center to the edge is going to be the same no matter what center and edge I talk about. So I know already just from the fact that this line AB, goes from the center of the circle to the edge of the circle. It is the same measure as this line BC because it goes from the center to the edge. So that tells me those two lines are the same length or congruent, and I write that by drawing little dashes. Now let's take a second and go to circle A. Circle A's center is over here, and we have the edge of the circle highlighted in pink. We see the radius for circle A is also AB, and we already know that all radius in circle A's are the same. So we have this radius too. So this radius, which I'm going to draw two lines in pink, is the same as this radius, which also has two lines in pink. Now it takes pretty simple logic to say, well, if AB is equal to AC, and AB is also the same length as BC, then AB, BC, and CA all have to be the same length. And basically, because every single line in this equilateral triangle shares the same radius, therefore all the sides are equal, and therefore it's an equilateral triangle. So we're going to continue seeing this over and over again in the next few questions. Pause the video now if you need a second to go over this question. Otherwise, I am moving on to the next one. Problem 2. A, B, and C are the centers of the three circles. So let's situate myself with my three circles. I see I have center circle here. That's circle A. I have circle B, which is over here to the right. And I have circle C, which is over here up top. How many equilateral triangles are there in the diagram? So I'm going to go with a black highlighter over here. And I'm going to say CB, I know is the same measure as CA. Then looking at this, I see that CB, and I know that because they're both the radius of circle C, but CB is a measurement of the radius of circle B, which tells me this line has to be the same length, and this line also has to be the same length, and this line over here even has to be the same length because all of those are radiuses of circle B. Now moving to circle A, this is a radius, which tells me this right here is a radius. And then I know that this is also here a radius. So each of these lines all have to be the same length, which means every single black line I just drew is the same length. I notice with circle C, rotating back, I see that this is also a radius, and this one over here is a radius. Also, the center of circle C all the way down to here, this is a radius. And I think that we've gotten to all of them. Now let's count our triangles. Each of these black triangles I know are equilateral triangles because each black line I know is the same. So I count 4. But I also see that we have this big triangle right here. Now because each side of this triangle is made up of 2 black segments, I know each side of that equilateral triangle is the same too, which leaves me to a total of 5 equilateral triangles that I found in this diagram. Take a second here to pause it before we move on to the next question if you need to. Problem 3. The diagram is a straight edge compass construction. A is the center of one circle and B is the center of another. Select all the true statements. So we've got all these statements down here. We have to figure out which ones are true. I'm going to quickly do what I've just been doing because I've seen it come up so many times. I'm going to identify all the radiuses that are congruent. So I'm starting with circle B. I know B to A is the same as C to B and D to C because they are all the same radius of circle B. Now A, I see the radius of A is A to B, which tells me that this radius and this radius is the same. Those are all the radiuses I have of the circles, and I know because they share this radius in the center that all these sides are congruent, or the same length. So using this information, I'm going to go ahead and do my multiple choice. Question A, or multiple select because it's all true statements. AC is equal to BC. Is AC equal to BC? Yep. Is AC equal to BD? Is AC equal to BD? Yep. Is CD equal to AB? Is CD equal to AB? We don't know anything about CD, so we don't know. We cross it out. Is ABCD a square? A, B, C, D. No, it is not a square. It also crosses over itself. Is ABD an equilateral triangle? A, B, D. Yes, so all sides are the same radiuses, so that is true. Does CD equal to AB plus AB? Is CD equal to AB plus AB? We don't know the size of these circles, and we don't know if that is true or not. So we're going to cross that one out. And there we go. We did the question. So if you understand the theory behind why these make equilateral triangles, it makes it a lot easier to go about thinking about these questions. Problem 4. Line segment CD is a perpendicular bisector of a line segment AB. So we have AB over here, and CD is the perpendicular bisector. Is the line segment AB the perpendicular line segment CD? So a perpendicular bisector bisects a line, which means we split it into two segments that are the same length at a right angle. However, this does not say anything about the line CD. So a perpendicular bisector bisects something, but that does not imply that whatever's being bisected will bisect the perpendicular bisect. So no, we cannot assume that. And this diagram makes a pretty good statement of this because you can see in this case, even though we don't use our visuals, although AB is bisected, CD is not bisected clearly because this one's so much smaller than that. And so this is a good example of where a perpendicular bisector is not bisected by the segment that it is bisecting. So pause that video if you need to go back over that because I just used the word bisector like 5 times. Problem 5. Here are 2 points on the plane, A and B. Using only a straight edge, could you find points in the plane that are the same distance from point A and point B? Explain your reasoning. So we want all the points that are the same distance. Well, let me start by finding all of the points that are the same distance from point B. Zoop, zoop. All of these points are the same distance from point B. Now let me find all of the points that are the same distance from point A. I'm going to use the same radius because this is the strategy that we keep using over and over again. I see 2 points. So every single point on this circle is the same distance from point B, and every single point on this circle is also the same distance from point A. I see 2 points where they're the same distance from each other. They're here and here. Hold on. We're just looking for a straight edge. I used a compass. So using only a straight edge, could you find points in the plane that are the same distance from point A and point B? I guess theoretically you could measure over and over again until you found one, but using just a straight edge, no, that would be difficult to do. 2, using only a compass, could you find the points of the plane that are the same distance from point A and point B? Well, we just did that. So we're done. Next question. Pause if you have to go back and rewatch that to process the difference between the 2 questions. But we used 2 circles to identify points that were equidistant from point A and point B, and that was just using a compass. We did not need a straight edge for that construction. Problem 6. In this diagram, line segment CD is the perpendicular bisector of line segment AB. Assume the conjecture, and that's just a math hypothesis, that the set of points equidistant from A and B is the perpendicular bisector. So that basically means that any point here has to be the exact same distance between A and B. Select all statements that must be true. Assume the conjecture that the set of points equidistant from AB is the perpendicular bisector. So every single point that is the same distance from AB falls somewhere on this line. Select all statements that must be true. So let's go through each statement together to identify the ones that must be true. Statement A. AM is equal to BM. Well, we know that CD is a perpendicular bisector of AB, so yes, it splits AB equally in half, with M being the midpoint, so these two would be the same. B. CM is equal to DM. Is CM equal to DM? Well, we just learned that a perpendicular bisector, while it does bisect a segment, and AB is the one that is being bisected, is not necessarily bisected itself, which means CM, we don't necessarily know if it's equal to MD. We don't know if CD was actually split in half, so we can't assume that. Is EA equal to EM? EA equal to EM. We don't know anything about E, so we can't make assumptions about EA or EM. Cross it out. Is EA greater or less than EB? Well, if this point right here, it's on the perpendicular bisector, and so we know that it is the same distance from A and the same distance from B, and then we shift it that way, we know definitively it got closer to A, and also it got farther away from B. So yes, this is something that we can assume from this question. Now, the last two we have is AM less than AB? Is AM less than AB? Well, AB is the whole segment and AM is half the segment, so yes, we can conclude that that one is true as well. Finally, is AM greater than BM? Is AM greater than BM? Well, we just identified here that AM is equal to BM, so AM cannot be greater than BM. So that one over there, we cross out as the wrong answer. All right, I think we have one more question left to go. Let's get started. Problem 7. Oh, 2 more questions. 3 more questions. Problem 7. The diagram was constructed with a straight edge and compass tools. Name all the segments that have the same length as segment AC. So we're going to do a similar thing which we did before, where we're just going to start with one circle, and we're going to highlight every single segment that's the same. So we're starting with AC. I see that AC is the radius of circle A, which means I immediately know he is the same length as segment AB because they're both radiuses. Then I nicely see that AB is the radius of circle B. Well, if AB is the radius of circle B, any other radius would be the same. So this guy's the same too. Which leads me to BE being the radius of circle E. And then this is the circle, this is a radius, this is also a radius. So they are the same, which means AC is the same length as AB, which is the same length as BE, which is the same length as ED. And we're done. Next question. Starting with 2 marked points, A and B, precisely describe the straight edge and compass moves required to construct the quadrilateral ACBD in this diagram. ACBD. Well, we start with A and B. First, we drew circle A with the radius, or circle B with the radius BA. Then we drew and center B. Then we drew circle A with center A and the same radius AB. Then I marked the intersections of circle A and circle B, and I called them C and D. Then I connected point C to point A to point D to point B, and point B to point C. Now, if you need to take a second to write this down or think about it on your own, go ahead and do that. But I'm going to move on to the next question. Question number 9. In this construction, A is the center of one circle and B is the center of another. Which segment has the same length as AB? This is an interesting question. Let's try to figure it out together. If A is the center of a circle, we know that any of the radiuses are going to be the same. So we know that AB here is going to be the same as CA. Are we done? I think we're done. That was it. Let's double check the other answers. I thought this was going to be a more complex question. Let's double check the other answers to make sure that they're not correct. Well, CE is not a radius, so we don't actually know anything about him, so we cross him out. CD is a radius. Nope, that's CAD. I'm sorry. CD, that's right here, also not a radius, so we don't know anything about him. CB is a diameter from one edge of the circle all the way to the other edge of the circle, so it's not going to be the same length as a radius, so we cross them out as well. So leaves us with answer D. We're done. All right, good work. If you like this video, make sure to like and subscribe so you can see more like this. I'm looking forward to seeing you in future videos. If you have any questions, make sure to put them in the comments and I'll get back to them as soon as I can. All right, see you next time.